All right, welcome back to the deep dive. If you're trying to keep up with technology and security, well, you know the feeling, right?
Oh, yeah.
It's just this constant flood, news, updates, alerts all the time, vulnerabilities, attacks, breaches. It feels like every single day there's something new.
Absolutely. And trying to figure out what's actually important, what really matters. It can feel like trying to drink from a fire hose, honestly.
Totally. It's overwhelming. And that's kind of why we're here. We've been spending our time digging through, a whole stack of recent findings, reports from our own research, really sifting through all that information.
Yeah. Trying to pull out the really crucial bits, the insights that help you cut through that noise.
Exactly. So our mission for this deep dive today is to get past the headlines. We're going to unpack some really significant developments we've seen recently in cybersecurity.
We want to look closely at what's actually happening, sort of explore the why behind it all, and see what it tells us about, the current threat landscape.
And what's really striking, looking at the material we've pulled together, is just how varied the threats are right now. It's quite a mix.
It really is.
We've got findings on everything from deep technical flaws hidden away in critical infrastructure software.
Foundational stuff.
Right, all the way to these really clever attacks that are all about exploiting human behavior, social engineering.
All right, tricking people.
And malware spreading because people download deceptive things, plus these bigger sort of systemic challenges like securing cloud services or even just the basic building blocks of the software we all use.
It really paints a picture of a complex battlefield. Lots of different fronts, different tactics being used.
Totally. So think of us as your guides, yeah. We'll walk through this material together. We're aiming for a conversation, exploring these things, hopefully finding those aha moments.
Yeah, where things click.
Exactly. And just making sure these sometimes complex ideas are, accessible. So let's dive in.
Let's do it.
Okay, so first up, let's unpack this really significant technical vulnerability we came across, the high severity one.
Right.
And these kinds of flaws, especially when they're buried deep in foundational infrastructure components, they can open up some really big doors for attackers.
And the finding we've zeroed in on here is exactly that. It's a critical vulnerability found in Cisco's Identity Services Engine. People usually just call it ISE.
ISE, right. So the core fact from our research is that Cisco pretty recently pushed out security patches to fix this specific critical flaw affecting ISE.
And to really get why this is such a big deal, you kind of need to understand what ISE actually does.
Okay.
Imagine your network security like a secure building. ISE isn't just a lock on a door. It's often the main security guard and the person holding all the keys, checking everyone who comes in.
Ah, okay. The gatekeeper.
Pretty much. When anyone or anything really, a user logging in, maybe a laptop connecting, even an IoT device tries to get onto the network, ISE is the system that figures out who or what it is. That's the identity part. Then it checks if that identity is legit. That's authentication, proving you are who you say you are, usually with, a password or something.
Makes sense.
And finally, it decides what that authenticated user or device is actually allowed to do. Which parts of the network can they reach? What resources can they access? That's authorization.
Got it. Identity, authentication, authorization.
Exactly. So for a lot of big organizations, ISE is like the central brain for controlling network access. Making sure it's secure is, well, it's absolutely critical.
So yeah, a critical flaw in that system, that's automatically a major problem.
Huge.
And this specific vulnerability, it's tracked as CVE 2025-2286. Our material describes it as an authentication bypass.
Authentication bypass. It sounds simple, but the implications are pretty profound.
Okay, break that down. What does it mean in practice?
It means basically instead of needing to provide valid credentials like a username and password or maybe a security certificate and having ISE check them, the attacker finds a way to just skip that whole step. They can get onto the network or into the system ISE protects without ever actually proving they're a legitimate user.
Wow. So it's like the security guard just waves them through.
Kind of, yeah. For certain visitors, the guard's just not there. They walk right past the checkpoint.
And what makes this particular vulnerability even more worrying, based on our findings, is how it works. It relates to something called a static credential.
Ah, yes. That detail is, well, it's deeply problematic from a security perspective.
Why is that? What is a static credential?
So a static credential isn't like a normal user password that you set and can change. It's a value. like a secret key or maybe a default password, that's actually hard-coded into the software itself by the developers.
Hard-coded, you mean like built right in?
Exactly. Baked into the code. It's not something the person running the system, the administrator, can easily configure or change.
Okay, I see the problem. So if an attacker finds this static credential, maybe they reverse engineer the software, or maybe it leaks out somehow, or maybe it was just like a leftover from development.
Right. Any of those could happen.
Then they have a key, a fixed, unchanging key.
Precisely. And in this specific Cisco ISE case, apparently this unchanging built-in credential allows an attacker to completely bypass the entire authentication mechanism.
Whoa.
Yeah, so it's not like stealing a regular user's password, which you could then reset. This is potentially a fundamental backdoor, built into the software structure. Once someone knows that static credential, they could have persistent unauthorized access. And you can't just revoke it by changing user passwords. It points to a serious architectural weakness.
Okay, that sounds bad. And the severity score reflects that, right? They rated 9.9 out of 10.
Yeah, 9.9 on the CVSS scale. That's the common vulnerability scoring system. It's the standard way the industry rates how bad these things are.
And 9.9 is pretty much at the top.
About as high as it gets. It signals this isn't just some theoretical issue. It's a critical flaw, likely easy for attackers to exploit over the network, and the consequences, if they do, are severe.
What kind of factors push a score that high, usually?
Typically, it's a combination of things. First, it can likely be exploited remotely, meaning the attacker doesn't need physical access. They can do it over the network. Second, it probably doesn't require the attacker to already be authenticated or need any special privileges. They can just attack directly. Third, it's likely low complexity, meaning, it doesn't take a genius hacker to pull it off if they know the vulnerability exists, and in this case, the static credential.
Okay.
And fourth, crucially, the impact is high. Exploiting it severely affects confidentiality, stealing data or integrity, messing with systems or availability, shutting things down. An authentication bypass in a core system like ISE, it ticks all those boxes. Remote, unauthenticated, probably low complexity once you have the key, and the potential impact on network access and data is, potentially devastating.
Right. And our research material explicitly says this flaw allows unauthenticated actors to carry out malicious actions.
Right. That phrase, unauthenticated actors, is the key consequence. It literally means anyone who can send network traffic to the vulnerable IE system could potentially exploit this. They don't need an account. They don't need stolen credentials. Nothing.
Just network access.
Just network access to the IE box itself.
Yep.
And malicious actions. Well, in a system that controls who gets onto the network, that could mean almost anything bad.
Like what?
Gaining deep access to internal network segments they should never be able to reach. Changing network security policies to allow their own malicious traffic through or maybe block legitimate users. Stealing sensitive data from servers inside the network once they've bypassed the gatekeepers. Or just causing chaos by disrupting IC's ability to function, maybe knocking parts of the network offline.
It sounds like a skeleton key, basically.
That's a good way to put it. A skeleton key that could potentially unlock the entire network controlled by that IES instance.
Okay, and here's where our findings show something really crucial for today's world. The source specifically points out that this vulnerability impacts cloud deployments on AWS, Azure, and OCI.
This is absolutely critical. It really highlights how the game has changed. For years, when we talked about critical infrastructure flaws, we often thought about hardware and software running in a company's own data center.
Right, on-premise stuff.
Exactly. But this report specifically calls out the big public clouds: Amazon Web Services, Microsoft Azure, Oracle Cloud Infrastructure.
So companies that have moved their network controls, maybe their ISE instances, into the cloud, they're vulnerable too.
That's right. If you're running Cisco IE in AWS or Azure or OCI, you are potentially exposed to this exact same very severe flaw. The risk isn't just contained within the old corporate walls anymore.
Right.
It lives right there in the cloud infrastructure that so many organizations now rely on. And it really drives home that point about cloud security being a shared responsibility.
How so?
Well, the cloud provider, like AWS or Azure, they secure the underlying hardware and the basic cloud platform. But you, the customer, you are still responsible for the security of the software you choose to deploy and run inside that cloud environment, like Cisco ISE in this case.
Ah, okay. So moving to the cloud doesn't automatically make everything secure.
Not at all. This finding really hammers home that organizations need to be just as vigilant about patching and securing their systems in the cloud as they are, or should be, in their own data centers. The urgency is exactly the same.
So let's connect this back to the listener. Why should you pay attention to a technical flaw like this, especially if you don't personally manage Cisco IS?
Well, first, it's a powerful illustration that even the most fundamental security layers, the ones designed to be the primary defense, can have critical hidden weaknesses. Second, it highlights just how absolutely vital a rapid, robust patching strategy is, not just for your laptops or servers, but for all critical infrastructure software, no matter where it's running on-premise or in the cloud. If your organization does use ISE, confirming these patches are applied should be like top priority right now.
And beyond that specific product.
Beyond ISE, it shows that really serious flaws can exist even in widely used, generally trusted enterprise software from major vendors. And critically, these flaws are present and exploitable in the cloud environments that underpin so much of modern business. It's a reminder that security is deeply linked to the integrity of these foundational, sometimes invisible, components.
That's a really clear takeaway. These technical flaws are one side of the coin, but as you said, attackers are also incredibly good at targeting the human element.
Oh, definitely. Technology has bugs, but people have biases, trust instincts, and pressures that can be manipulated. The human factor is often the path of least resistance for attackers.
Which leads us perfectly into our next area. We want to explore attacks that specifically leverage that human trust and also the way we all interact with common applications and software every day.
Yeah, we're shifting focus a bit here, moving from that deep infrastructure layer up to the applications people use and the users themselves.
So first up in this category, our research flagged a really interesting, though definitely concerning, example involving phishing campaigns and fake applications. Specifically, some details emerged about a group our sources call UNC 6040.
Yes, the core finding, reported by Google's threat analysis group, which we reviewed, lays out the activities of this group, UNC 6040, and they're using voice phishing specifically to target Salesforce instances.
Okay, let's unpack that. Who is this UNC 6040 group? What's their goal?
Google describes them as a financially motivated threat cluster. And that motivation, financially motivated, is really the key. Unlike, say, state-sponsored groups who might be after secrets or causing disruption, this group is basically in it for the money. Their goal is almost certainly profit, which means they're focused on getting hold of assets they can turn into cash. Usually that means valuable data they could steal and then either sell or, more likely, use for extortion.
And their method is vishing. Remind us quickly, what's voice phishing?
Vishing is just phishing, but done over the phone or through voice calls. Instead of a fake email trying to get you to click a link or give up your password, the attacker actually calls you up. They'll pretend to be someone legitimate, maybe from your IT department, a software vendor like Microsoft, maybe even someone else inside your company. They use social engineering tricks during the call to build trust and convince you to do something.
Like what?
Like reveal sensitive info, maybe give them remote access to your computer, or, as in this case, install some software.
And why might vishing be more effective sometimes than email? How does it exploit trust differently?
Well, a live phone call can feel more immediate, more personal. A skilled attacker can sound really convincing professional, maybe urgent, knowledgeable about your company or systems. They can react to your responses in real time, answer your questions, build rapport. It can bypass some of the skepticism people might have towards a random email. That human interaction, even though it's fake, can lend it credibility.
And in this campaign, their target is Salesforce. Why go after Salesforce specifically?
Salesforce is huge. It's one of the biggest customer relationship management or CRM platforms out there. For many companies, it's the central hub for all their customer interactions and sales data.
So it holds a lot of valuable stuff.
A ton. We're talking customer names, contact details, purchase histories, sales pipelines, internal notes, potentially financial details, marketing plans. It's an absolute goldmine for a group whose goal is data theft and extortion. Getting inside a company's Salesforce instance gives them direct access to the crown jewels, data they can easily hold for ransom or sell.
And the specific tactic our research mentioned involves using a fake data loader app. What's that about?
Okay, so a data loader in the Salesforce world is a legitimate tool. Admins or power users use it to handle large amounts of data, importing records, exporting backups, maybe doing bulk deletions. It's for mass data operations.
Got it. So how does a fake one fit into a vishing attack?
So the attacker, during that vishing call, pretending to be IT or maybe Salesforce support, they'd likely invent some reason why the user needs to use this data loader tool right now.
Like, there's a problem with your account, you need to run this tool to fix it.
Exactly. Or maybe We're rolling out an update. Please install this new version, or you need this utility for compliance reasons. Something plausible. Then they direct the user to download and install what looks like the real data loader app.
But it isn't.
Right? It might be hosted on a fake website that looks like Salesforce's, or maybe a file sharing link. The user downloads and runs it, thinking it's a legitimate work tool. But it's actually malware.
And what does the malware do then?
The fake app could do a few things. It might pop up a fake login stream to steal the user's Salesforce username and password when they try to use it. Or it might be more sophisticated, maybe trying to grab session tokens to bypass login altogether. Once it's running, it could start scraping data directly from the user's Salesforce session, or install a more persistent backdoor onto the user's computer for later access, or use the compromised credentials to log in itself and just download everything it can find.
Wow. So the whole deception hinges on making the user trust that this download is necessary and safe?
Precisely. Convincing them they're installing a helpful tool for their job, when really they're installing the attacker's key to their data.
And the ultimate goal, the source stated, is large-scale data theft and subsequent extortion.
Exactly. The phone call, the fake app, those are just the ways in. The real prize is getting inside Salesforce, grabbing all that valuable customer and business data, and then turning around and saying to the victim company, pay us a hefty ransom, or we leak all this sensitive data online, or sell it to your competitors.
Yeah.
It's a very clear, financially driven attack from start to finish.
This campaign is a really stark example of blending social engineering, the Vishing call, with technical deception, the fake app.
It really is.
Yeah.
And it shows that even platforms like Salesforce, which are generally secure, technically, can be compromised by targeting the users. It comes back to that human element being the weakest link sometimes.
So for you listening, if your organization uses Salesforce or really any major cloud application holding sensitive data, you're on the front line here.
Absolutely.
Yeah.
This underscores how vital security awareness training is, and it needs to specifically cover things like phishing tactics. Employees need to know how to recognize suspicious calls, understand that legitimate support rarely asks you to download software from random links during an unsolicited call, and know the proper procedure for verifying requests, like hang up and call back the official support number, or check with your internal IT team through approved channels. Just being wary of unexpected requests, even helpful-sounding ones, is crucial.
That makes a lot of sense. Be skeptical, verify. Okay, so social engineering works, and it's often the way attackers deliver malware. Which brings us nicely to our next finding, focusing on a specific type of malware being spread through, again, deceptive downloads.
Right. We're looking at some recent findings about a new variant of malware known as Chaos, R-A-T. Okay, the core fact from our research is that this updated version is being distributed by tricking people into downloading what they think are legitimate, useful tools.
Yeah. So, first off, what is Chaos R8? The RAT part stands for Remote Access Trojan.
Trojan, like the Trojan horse. Hide something bad inside something seemingly good.
Exactly. And remote access means its purpose is to give the attacker unauthorized remote control over the computer it infects.
How much control are we talking? Pretty much full control, usually. Once Chaos RAT is running on your machine, the attacker can typically do things like browse and steal your files, run commands as if they were sitting at your keyboard, capture your keystrokes to get passwords, potentially access your webcam or microphone, use your computer to launch attacks against other people. It essentially turns your machine into their remote puppet.
Okay, that's nasty. And the source mentioned this is a new variant. What does that tell us?
It tells us the attackers aren't static. They're actively working on this malware, updating it. A new variant might have new features. Maybe it's better at hiding from antivirus software, maybe communicates differently, or maybe it's adapted to spread in a new way. It shows it's an evolving threat, not some old piece of code.
And significantly, the research highlighted that this variant targets both Windows and Linux systems.
Yes, and that's quite noteworthy. A lot of malware, especially the kind aimed at widespread infection for profit, historically focused heavily on Windows, just because of the sheer number of users.
Right.
Targeting both Windows and Linux broadens the potential victim pool significantly. It includes not just regular desktop users, but potentially servers, developers, system administrators. Lots of critical infrastructure runs on Linux. It suggests the attackers are either quite capable, or the way the malware is built makes it relatively easy to adapt for both platforms.
And the specific distribution method described, it sounds like classic social engineering again. tricking victims into downloading a network troubleshooting utility for Linux.
This is a really clever, targeted approach. Think about who downloads network troubleshooting tools, especially for Linux.
Probably tech-savvy people, sysadmins, network engineers, developers.
Exactly. People who often have higher levels of access or manage important systems. Gaining control of their computers can be incredibly valuable for an attacker. It might give them a foothold into a corporate network or access to sensitive code or infrastructure controls.
So how does the trick work in this case?
The attacker creates a malicious program that looks like, and maybe even does some basic functions of, a real network utility for Linux. They give it a plausible name, maybe a fake website or description. Then they try to get it in front of those target users.
How?
Maybe they post links on technical forums. Maybe they compromise a legitimate download site. Maybe they use targeted emails or chat messages. The victim, needing or wanting that kind of utility, finds it, downloads it, and runs it.
Thinking it's going to help them troubleshoot their network.
Right, but hidden inside, or maybe downloaded alongside the fake utility, is the Chaos RET malware. It gets installed silently in the background. The user might get a basic utility or maybe just an error message, but the real payload, the RET, is already running. It's hiding the malicious intent within something seemingly useful and relevant to the target's work.
The research also mentions some technical details. It's written in Go, and it's open source. What's the significance there?
Okay, the language, Go, or Golang, as
Okay.
it's often called, has become quite popular for writing malware recently.
Why is that?
One big reason is that Go makes it really easy to compile the same source code into working programs for different operating systems: Windows, Linux, macOS. It streamlines cross-platform development. So that fits perfectly with the finding that this RAT targets both Windows and Linux. The choice of language helps enable that.
Okay, makes sense. And the open source part.
That could mean the source code for Chaos RAT, or at least a base version of it, is publicly available somewhere, maybe on a site like GitHub. If that's the case, it dramatically lowers the barrier for other attackers. They don't have to build a RAT from scratch. They can just take the existing Chaos RAT code, maybe tweak it a bit, add their own features, and deploy it. It helps explain why we see new variants popping up. Lots of people might be modifying and using the same core code. It shows how open source tools meant for good can be repurposed.
So putting this all together, what's the main takeaway from this Chaos RAT finding? Why should people listening be aware?
It shows a few key things. One, how modern programming languages like Go and even open source availability can make creating potent cross-platform malware easier for attackers. Two, it reinforces that social engineering isn't just about fake login pages and emails. It's used to deliver serious malware by disguising it as software people might actively look for, especially technical tools.
Right.
So for you, the listener, it's a huge reminder. Be incredibly careful about where you download software from, especially utilities, tools, anything that isn't from an official vendor site or a trusted verified source like a standard operating system package manager. Double-check URLs, look for reviews, be suspicious of things offered on forums or unexpected links. Verify before you execute. Malware doesn't always come knocking politely through email. Sometimes it's hidden in the helpful tool you went looking for yourself.
That's a really sobering thought. Okay, so we've seen attacks targeting infrastructure, applications, and users directly through deception. But what about the bigger picture, the sort of ongoing challenges in just protecting data and systems in the way we work now? Thinking about cloud services, SaaS, and even how software gets built.
Exactly. That's where we wanted to broaden the view for this last section. We're looking at two really significant evolving challenges that are shaping a lot of cybersecurity efforts right now. First, the difficulty of securing data that lives inside software as a service, or SaaS, platforms. And second, the risks that come with the software supply chain itself, how the components that make up our applications are sourced and secured.
Okay, let's tackle securing SaaS data first. The core finding from our research here seems pretty fundamental. The old ways of preventing data leaks, traditional data leakage prevention, or DLP, they're just not cutting it anymore. They're struggling to keep up with how we use SaaS in browsers today.
That's right. Traditional DLP tools were really designed for a different era, a different way of working. Their main job was to stop sensitive data leaving the company network.
How did they do that?
Mostly two ways. They'd scan files on people's computers, endpoints, looking for patterns like credit card numbers or maybe internal project codes. And they'd sit at the edge of the corporate network, inspecting traffic going out, looking for those same sensitive patterns trying to leave the building.
The idea was build a strong wall, monitor the gates.
Pretty much. But think about how most businesses operate now. We rely heavily on SaaS platforms, right?
Yeah, things like Google Workspace, Microsoft 365, Salesforce, we just talked about them, Slack, maybe generative AI tools.
Exactly. And in that world, the data doesn't mostly live in files on your local C drive anymore. It lives inside those cloud platforms. It's database entries, it's chat messages, it's content in online documents, it's prompts you type into an AI, and you access it all through your web browser.
Okay, so why does traditional DLP fail there?
It's a fundamental mismatch. Traditional DLP is looking for files and monitoring traffic crossing the old network perimeter. But in the SaaS world, the sensitive data often isn't in a neat file package. It might just be text on a web page.
Ah.
And crucially, as our research pointed out, this data often rarely appears as traditional files or crosses networks in the way those old DLP tools expect. When you copy some customer info from Salesforce in your browser and paste it into Slack, also in your browser, where did that data cross the old corporate network boundary?
Good point. It probably didn't. It might have all happened within the browser or maybe server to server between Salesforce and Slack in the cloud.
Exactly. The data movement, the potential leak, happens completely outside the view of that traditional network-based DLP sitting back in the office firewall. It's blind to it.
So the old fortress model doesn't work when the valuable stuff is already outside the walls, living in these cloud services and accessed directly.
Pretty much. Sensitive data can leak out from the SaaS app or via the browser in ways that totally bypass those older controls.
Yeah.
Think back again to that UNC 6040 attack on Salesforce. If they got in and stole data using a compromised account, that data theft could happen entirely within the cloud, never touching the victim's corporate network where the old DLP might be watching.
Okay, so for you listening, especially if your organization is using SaaS, and let's face it, who isn't? What's the key takeaway here?
It means you really can't assume your traditional DLP tools are adequately protecting your sensitive data in the cloud. You have to understand their limitations. This finding strongly suggests organizations need to look at more modern security solutions.
Like what?
Solutions designed for the cloud and browser world. Things that can plug directly into SaaS apps using APIs to see what's happening inside. Tools that monitor user activity within cloud platforms, maybe looking for risky behavior, or advanced endpoint security that watches what's happening in the browser itself, regardless of whether the user's on the corporate network or working from home.
So shifting the focus inwards.
Yes, and focusing much more on data governance within the SaaS apps themselves.
Yeah.
Do you know what sensitive data is in your Salesforce, your Google Drive, your Slack? Is it properly classified? Are the access controls and sharing permissions locked down tightly inside those platforms? You can't just rely on perimeter security anymore. You need security controls that travel with the data wherever it lives.
It really is a big shift, moving security from the edge into the core applications and data flows.
It has to be. And just like securing how we use software is changing, well, so is securing how that software gets built in the first place.
Which brings us to the other major challenge area, the risks lurking in the open source software supply chain. The core fact our research flagged here is pretty stark. Multiple malicious packages keep getting found in the big open source repositories, places like NPM, PyPI, and RubyGems.
Yeah, and to grasp why this is so critical, you need to think about how nearly all modern software gets made. Developers today rarely write everything from scratch. It's just not efficient.
They reuse code, right? Libraries, components.
Exactly. They rely heavily on pre-built pieces of code, open source libraries, packages, frameworks that handle common tasks. Things like making web connections, processing images, building user interfaces. They download these building blocks from central repositories. NPM is the main one for JavaScript developers, PyPI for Python, RubyGems for Ruby, and so on.
Okay, so the supply chain is like the journey of these components.
Precisely. It's the whole path from the original person or team who wrote that open source component to it being uploaded to the repository, then downloaded by another developer who includes it in their application, and finally that application ending up with you, the end user.
And attackers are targeting this chain.
They absolutely are. It's become a major focus. The attack vector is basically sneaking malicious code into those widely used open source packages, either by compromising the original package or by uploading new malicious packages disguised as useful ones.
Why is that such an effective tactic?
Because of leverage. If an attacker can compromise just one popular open source package that maybe thousands of other projects depend on, they can potentially infect all those downstream applications. And by extension, all their users in one go. It's like poisoning the well higher up the stream. It's incredibly efficient for achieving widespread compromise.
And our research mentions specific examples of what these malicious packages actually do. It wasn't trivial stuff.
No, definitely not. The examples really show the range and severity. Some were designed to steal cryptocurrency, targeting developers or users who might have crypto wallets on their machines.
Okay, direct that.
Others were purely destructive, designed to just erase code bases or delete files after being installed. Imagine that hitting a developer's machine, wiping out their project.
Devastating.
And others focused on stealing credentials for other services, like grabbing Telegram API tokens, which would then be used to take over accounts or access sensitive chats. So it's financial theft, sabotage, credential theft, serious impacts.
And mentioning NPM, PyPI, Ruby gems, it really stresses that this isn't just a problem in one corner of the software world. It's hitting major development ecosystems.
Exactly. These are foundational platforms for building a huge amount of the software we all rely on every single day. Websites, mobile apps, business software, you name it.
So if this is such a powerful attack vector, why is it so hard to stop? Why can't we just check all the packages?
It's incredibly difficult for a few reasons. First, just the sheer scale. There are millions of open source packages out there, constantly being updated, often by volunteers. Second, the complexity. A typical application might depend on dozens, maybe hundreds of these packages, and each of those packages has its own dependencies. It creates these huge, intricate dependency trees.
Like a web of interconnected code.
Exactly. It's practically impossible for any single developer or company to manually audit every line of code and every single component they use. Third, there's historically been a lot of implicit trust in the open source community and these repositories. Attackers are exploiting that trust.
Yeah.
And finally, the malicious code itself can be really hard to spot. It might be just a few sneaky lines added to a huge, legitimate code base. Or it could be obfuscated, deliberately written to be confusing and hide its true purpose. Or it might be designed to lie dormant for a while and only activate under specific conditions. It's like trying to find a single poison needle in a gigantic, constantly shifting haystack.
Okay, so putting this finding into perspective, what does it mean for you, the listener, whether you write code or just use apps?
It impacts everyone, really, because pretty much all software today contains open source components. It means the security of the apps on your phone, the websites you visit, the tools you use for work. It all depends not just on the company that put the final label on it, but also on the security and integrity of this vast distributed network of component creators and repositories.
It shakes the foundation a bit.
It does. For developers, it's a direct, major challenge. They need to adopt tools and practices to scan dependencies for known vulnerabilities, check package reputations, maybe limit their reliance on less vetted components. For regular users, it's a reminder that software security is layered and complex. Patching the final app is important, but the risk might originate much earlier in the building blocks it was made from. It really pushes us to ask harder questions about how we establish and verify trust throughout the entire software lifecycle. How do we ensure the integrity of the digital foundation we're all building on?
That really does give you a lot to think about, the interconnectedness of it all.
Yeah, the complexity is just immense.
Okay, so let's quickly recap the ground we covered in this deep dive. We started with that critical technical flaw, the authentication bypass in Cisco ISE, impacting network access control, even in the cloud.
The static credential issue.
Right. Then we shifted to the human element, looking at how attackers use vishing and fake apps to target platforms like Salesforce, that UNC 6040 example, and how malware like Chaos RAT spreads by tricking users into downloading fake utilities.
Combining social engineering with malware delivery.
Exactly. And finally, we zoomed out to look at those broader systemic challenges. The struggle for traditional DLP to secure data in the SaaS era, and the pervasive, difficult problem of securing the open source software supply chain.
Yeah, exploring these different facets, infrastructure flaws, user deception, application security, supply chain integrity, hopefully helps connect the dots. It gives a clearer, maybe more nuanced picture of the cybersecurity landscape right now.
It's definitely complex, definitely layered, always changing. But understanding these specific kinds of threats and challenges is key to navigating it right.
Absolutely.
And whether you're the one making the big tech decisions for your company, or you're building software, managing systems, or honestly, just trying to stay safe online as a user, these insights matter.
They really do.
They show just how varied the threats are, blending deep technical knowledge with clever psychological manipulation and targeting everything from the network foundation right up to the code components themselves.
It highlights the adaptability of the attackers. They're constantly probing, constantly looking for the weakest point, whether that's a technical bug, a process gap, or a human vulnerability across all these different layers.
Which brings us to a final thought, something for you to maybe chew on after listening to all this. Given this sheer diversity of threats we've talked about today, exploiting infrastructure flaws, tricking people with fake apps, poisoning the software supply chain, the challenges of cloud data, what does this tell us about where cybersecurity is heading?
That's a great question.
Is that old idea of just building a strong wall around your network, a fixed perimeter, is that becoming, well, kind of obsolete?
It certainly feels less sufficient on its own.
And is the focus shifting, maybe has already shifted, to a world where security is much more about continuous verification, constantly checking identity, constantly monitoring behavior across all these distributed systems, maybe even assuming you can't fully trust any single component or network connection?
Moving towards more of a zero-trust mindset, perhaps. Scrutinizing everything.
Maybe. And if so, how do we balance that? How do we as individuals, as companies, as a society, balance the usability and the efficiency and the connectivity we need from all these tools?
Yeah, the things that make modern life and work possible.
With this increasingly complex, seemingly ever-present need for vigilance, for security at every single step, every layer, all the time.
That's the fundamental tension, isn't it? Convenience versus security. Openness versus control. How do we find the right equilibrium in this constantly evolving digital world?
Something to think about as you go about your day.
Definitely a challenge that's not going away anytime soon.